All right, welcome to day 3. We're going to be talking about Newton's first law. Newton had 3 laws, day 4 and 5. We're going to talk about second and third law, but today we're going to talk about Newton's first law. Here we go. Let's try that again. Newton first law. So Newton was a guy that really developed calculus and a lot of math. And he actually started thinking about things like gravity and stuff like that and interaction of objects. So he started thinking about those things and he started making formulas for that. So Newton's first law states an object in motion will stay in motion and an object at rest will stay at rest unless both an object in motion and an object at rest will stay in motion or stay at rest unless acted on by an unbalanced force. So this is what we call literally momentum. If it's in motion already, it has momentum. It's going to continue to stay in motion. If it's at rest, it has 0 momentum. It's not going to move on its own. Okay? So objects in motion stay in motion unless acted on by an unbalanced force, and objects at rest stay at rest unless acted on by an unbalanced force. So this is Newton's first law. So we're going to be looking at that. We're going to apply a force to something and then let it go and see what happens to that object. So we're going to be using force diagrams. We're going to be using motion diagrams, all in the simulator that you're going to be using in a minute. So once again, objects in motion will stay in motion, objects at rest will stay at rest, unless acted on by an unbalanced force. So you should be on this page, click on the box, and you should get to this. Now, we're not going to stay in this net force. That was yesterday, right? We're going to be over here in motion today. So click on motion, click on it again, and it will take you to it. So what you're going to be doing here is you're going to be looking at the motion of this object, okay, after you apply a force to it. So you're going to apply a force and then you're going to let it go. You're going to find out what happens to it. Does it continue? Does it slow down? Does it speed up? What does it do? All right, here we go. So I'm going to apply, all right, a force to it. Notice that it's speeding up. I'm constantly applying a force. What happens if I go to a 0 now? The object will stay in motion at that force. So you can see the little blocks moving by, right? So it's going to keep going at that force. Up, up, up. I want to slow it down, slow it down, slow it down, slow it down, slow it down. And it's going to come to a stop. And then it's going to actually go the opposite direction, because it's going to applying a force this way. So there's a skateboard with a box on it. What happens if I want to put a refrigerator on it? Boom! I got to apply a bigger force. Okay? Or I can stop it, right? So what happens if I put a lot on there? Boom! Alright, so now we got a lot on there, right? So let's get this thing to reset. Boom. Let's put that refrigerator on there. Put another crate on there. Let's throw some values on it. Okay? We can even look at the speed of the object. Boom. So I got 300 kilograms. Okay? 300 kilograms. It's a lot of mass. So let's find out if I do 50. It's going to move very slowly. If I do 100, a little bit more, a little bit more, a little bit more, a little bit more. I'm applying 300 newtons of force. 500. This is the max amount. So you can see my speed increasing. Alright, let's put, what happens if I just knock it down to 0? My speed stays the same. It doesn't move. I'm going at constant speed. There's no more acceleration. Okay? So I want you to play with this. I want you to do the lab. I want you to have fun with it. And then I'll see you on lab day.